The Interstellar Boundary Explorer, or IBEX spacecraft, is unique in NASA's heliophysics fleet. Instead of studying the face of the Sun, IBEX looks at the very edge of the Sun's reach, starting at about 8 billion miles away. The region begins with the termination shock, where the solar wind abruptly slows down. It ends with the heliopause, the boundary between the solar wind and interstellar space. Between the two is the heliosheath, a teardrop-shaped region sculpted by the pressure of the interstellar medium. IBEX is also different because it makes its images from particles instead of light. Some of the atoms it detects originally came from the Sun as charged particles, traveled out to the heliosheath, bounced back, and gained electrons to make them neutral. Others were neutral to begin with and came from interstellar space. Both kinds are called energetic neutral atoms, or ENAs for short. Over the course of 6 months and many orbits, IBEX can paint a picture of the entire sky in ENAs. For easier viewing, the sphere of the sky is unwrapped and projected onto an oval, much like how a map of the spherical Earth is projected onto a rectangle. The colors correspond to how many atoms hit the detector from a particular region. Violet represents few atoms, and the colors move up to red, which represents many atoms. IBEX can also tell how energetic each atom was, and, much like filtering light to show one color, create an all-sky map of each energy level. Viewing the sky this way can reveal some startling things about the edge of the solar system. IBEX is led by Dave McComas of the Southwest Research Institute in Texas. Its first major discovery was a ribbon of bounced ENAs showing unexpected activity at the edge of the solar system. Subsequent measurements show that this ribbon changes over time. IBEX has also measured ENAs from the interstellar wind, giving scientists a clearer picture of its composition. Surprisingly, it turns out that the local interstellar material is different from the Sun, and the wind is slower and coming from a different direction than previously thought. Closer to home, IBEX has used ENAs to help understand the Earth's magnetosphere better, and has even observed the solar wind reflecting off the Moon. As IBEX continues to scan the Sun's horizon, who knows what other discoveries it will make?